In this first video, we're just revising what we did the other week, finding the equation of a straight line in 3 dimensions, specifically finding the vector equation of the straight line in 3 dimensions. And what we saw is any straight line in 3 dimensions, we can find the coordinates of any point on that line by firstly taking any fixed point on the line and creating its position vector. That gets us from the origin onto the line. And remember, we want to find the position vector of any point on the line. The next thing I need is a vector that describes the direction of the line. So I pick another point on the line and I create a vector from the fixed point to another point on the line. Then, from my fixed point, if I add a scalar multiple of my direction vector, I'm defining every single point on that line. In fact, if we look at this point here, and maybe I thought I could do that in a different color. Well, just watch that point. It travels up and down the line we started with. If the scalar multiple is any real number. And remember, the vector equation of the line is actually the equation that gives you this vector, which we called r. That's the position vector of any point on the line. It's important to remember that the vector equation of a straight line gives us the position vector of any point on the line. That's the red vector in this case. And what we've done is make sure that every single point with position vector given by the red vector lies on that line. So that's just what we revised the other week. And what we're doing in the next video is extending this idea to have, instead of one direction vector, we have 2. And simply that takes us into another dimension where instead of the equation of a straight line, we have the equation of a 2-dimensional object, which is a plane.